right now, beneath miles of black, freezing water, in a place where sunlight has never reached and never will. Something is alive, something that should not exist. The deep ocean. A world so hostile, so crushingly violent, that it makes the surface of Mars look hospitable. The pressure alone would flatten a human body like paper. The temperature hovers barely above freezing, and the darkness is so absolute, so total, that creatures born here will live their entire lives without ever knowing what light looks like. And yet, life thrives here. Not just survives, thrives. Creatures that glow in eternal darkness, animals that eat without mouths, fish that see through their own transparent skulls, organisms that live for centuries without ever encountering another living thing. This is no ordinary ecosystem. It is a gallery of impossibilities, a realm where the rules of biology bend, break, and reassemble into something we can barely recognize. And the deeper you go, the stranger it gets. You think you understand life on this planet. You think evolution follows a logic you can trace. But nothing in the deep ocean makes sense. And that is exactly what makes it so terrifying. The deep ocean begins where the light ends. Below 200 meters, the ocean transforms. This is the twilight zone, a vast corridor of fading blue where the world above becomes a distant memory. Here, the last traces of sunlight dissolve into nothing, and creatures exist in a permanent state of half-darkness, a ghostly limbo suspended between the sunlit surface and the abyss below. And in this dim, haunting space, life has evolved in ways that defy everything we understand about survival. The most extraordinary adaptation in the twilight zone is bioluminescence. The ability to create light from within your own body. It sounds like science fiction, but in the twilight zone, nearly 90% of all creatures produce their own light. Not for warmth, not for comfort, for war. The anglerfish is perhaps the most iconic example. A creature so grotesque, it looks like it was designed by a nightmare. It dangles a glowing lure from a modified dorsal fin on its head, a biological lantern powered by millions of symbiotic bacteria that produce light through chemical reactions. In the total absence of sunlight, prey is drawn to that tiny flicker like moths to a flame. But the light is a trap, a death sentence disguised as hope. The moment a smaller fish approaches, mesmerized by the glow, the anglerfish strikes with a jaw that can expand to swallow prey twice its own size. Its teeth, translucent and needle-thin, angle inward like barbed wire, so that nothing escapes once it enters. The anglerfish does not chase its food. It does not need to. It simply waits in the darkness, patient and still, letting the light do the killing for it. But the anglerfish's strangeness does not end with its hunting. Its reproduction is one of the most disturbing processes in the animal kingdom. The male anglerfish, a fraction of the size of the female, bites into her body and fuses permanently. His blood supply merges with hers. His organs dissolve. His eyes waste away. Eventually, nothing remains of the male except a pair of gonads attached to the female's body, ready to fertilize her eggs on demand. He does not live alongside her. He becomes part of her, a parasitic appendage absorbed into her flesh. In the deep ocean, even love is a form of consumption. But the anglerfish is not the only creature weaponizing light in the twilight zone. The firefly squid uses bioluminescence in an entirely different and far more sophisticated way. Thousands of tiny light-producing organs called photophores line its entire body, creating a shimmering blue glow that disrupts its silhouette when viewed from below. Predators looking upward from the deeper darkness see only scattered points of light, indistinguishable from the faint glow filtering down from the surface above. This is counter-illumination, a form of camouflage so advanced that it took researchers decades to fully understand how it worked. The squid does not hide in the dark. It hides in the light. It becomes the light. And in doing so, it vanishes completely. And then there are the creatures that use bioluminescence not as a weapon or a cloak, but as a scream. The Atolla jellyfish, when attacked by a predator, does not flee. It cannot. It has no speed, no armor, no venom. Instead, it triggers a spinning wheel of brilliant blue light across its bell, a frantic, pulsing alarm that radiates outward into the surrounding darkness, like a distress flare. This is not a call for help in any conventional sense. It is a burglar alarm. The flashing light is designed to attract even larger predators to the scene, creatures big enough to attack whatever is currently trying to eat the jellyfish. It sacrifices its own invisibility to summon something far worse than itself. A desperate, brilliant act of survival through chaos. It cannot save itself, so it calls in something that can. In the twilight zone, light is not a gift. It is a weapon, a lure, a shield, and a scream. And every creature here has learned to wield it with terrifying precision. But descend further, past the twilight zone, past 1,000 meters, and you enter a world that feels less like Earth and more like another planet entirely. The midnight zone. Here, sunlight does not exist, not a trace, not a photon. The temperature drops to near freezing, and the pressure is enough to crush a submarine like an aluminum can. Over 1,000 pounds per square inch presses against every surface, every cell, every molecule of everything that dares to exist here. The human body would be destroyed in seconds, and yet the midnight zone is not empty. Far from it. It is teeming with life so alien, so fundamentally bizarre, that when scientists first pulled specimens to the surface, they genuinely questioned whether they had discovered organisms from another world. The giant isopod is a creature that looks as though it crawled out of a prehistoric fever dream. A deep-sea crustacean that can grow to over 2 feet long, its body is covered in thick, armored plates. Its compound eyes, among the largest relative to body size in the entire animal kingdom, reflect light with an eerie, unsettling yellow glow. But the most disturbing thing about the giant isopod is not its appearance. It is its patience. Its metabolism is so impossibly slow that it can survive for years without consuming a single morsel of food. One specimen held in captivity in Japan reportedly went over 5 years without eating. 5 years. No food, no visible deterioration. Just existence, patient, silent, and unrelenting in the dark. It does not hunt. It does not search. It simply waits. For months, for years, until something edible drifts close enough to consume. In a world where meals may come once a decade, the giant isopod has evolved to outlast starvation itself. And when food does arrive, whether a whale carcass drifting down from the surface or the remains of some creature that succumbed to the pressure, The giant isopod gorges itself with a ferocity that contradicts its usual stillness. It can eat so much in a single feeding that its body swells visibly, storing enough energy to sustain itself through another years-long fast. It is a creature built entirely around one principle. Patience is the ultimate weapon when the world gives you nothing. The barrel-eye fish is equally unsettling, but for entirely different reasons. Its head is completely transparent. You can see directly through its skull to the soft, green, tubular eyes sitting inside, pointing upward, scanning the water above for the faint silhouettes of prey. For decades, scientists believed its eyes were permanently locked in this upward gaze, frozen in place. But in 2009, researchers at the Monterey Bay Aquarium Research Institute made a startling discovery. The barrel eye can actually rotate its eyes forward within its transparent dome, allowing it to look directly at what it is eating. That see-through skull is not a vulnerability, it is armor. The transparent shield protects its eyes from the stinging cells of siphonophores, the jellyfish-like colonial organisms it feeds on. This creature evolved a glass head not as a flaw, but as a survival mechanism. In the deep ocean, even the things that look like weaknesses are weapons. And then there is the black swallower, a fish that embodies the grotesque desperation of deep-sea life in its purest form. No larger than 10 inches long, the black swallower can consume prey more than twice its length and 10 times its own body mass. Its jaw unhinges. Its stomach stretches into a translucent, grotesque balloon. The consumed fish clearly visible inside like some macabre display case. In a world where meals are vanishingly rare, the black swallower does not waste a single opportunity. It eats everything, all at once, even if the meal kills it. Specimens have been found dead at the surface, their stomachs ruptured by prey too large to digest before decomposition gases forced them upward from the deep. The fish literally ate itself to death. And yet, evolution favored this strategy. In the deep ocean, starvation is so constant and so lethal a threat that nature selected for a creature willing to die from abundance rather than risk missing a single meal. But the true heart of deep ocean strangeness lies even further down. In the abyssal and hadal zones, where the ocean floor drops away into trenches deeper than Mount Everest is tall, the Mariana Trench, plunging nearly 36,000 feet below the surface, is the deepest known point on Earth. The pressure here exceeds 15,000 pounds per square inch. No light has touched these depths in the entire history of the planet. And yet, life persists. In 2014, scientists discovered a new species of snailfish swimming at depths exceeding 26,000 feet in the Mariana Trench. Small, translucent, and eerily ghost-like, the snailfish has no business existing at these pressures. Its bones are barely calcified, more cartilage than skeleton, allowing its body to flex and compress rather than shatter under the weight of the ocean above. Its cells contain high concentrations of a chemical called trimethylamine N-oxide, a molecular stabilizer that prevents its proteins from being crushed and deformed by the immense pressure. This creature did not simply adapt to the deep. It rebuilt itself from the molecular level upward, rewriting its own biology to exist in a place that should be lethal to all complex life. And the snailfish is not alone down there. In 2020, researchers using deep-sea landers captured footage of enormous swarms of amphipods, tiny shrimp-like creatures, feeding on bait at the bottom of the trench. Thousands of them, crawling over each other in a frenzy, thriving at pressures that would liquefy human tissue. The Mariana Trench is not a dead zone. It is an ecosystem. a hidden world of scavengers and hunters and survivors, separated from us by nothing more than water and darkness and unimaginable force. And at the very bottom of the ocean, in the deepest hadal trenches, scientists have discovered thriving colonies of xenophyophores, single-celled organisms that can grow to over 4 inches across. One cell, 4 inches. These are among the largest single-celled organisms ever discovered, and they carpet the floors of the deepest places on Earth in dense, sprawling communities. They feed on organic matter that drifts down from the surface, a slow, ghostly rain of dead material known as marine snow. Fragments of dead plankton, fecal matter, and decomposing tissue falling for weeks through miles of black water before settling on the bottom. In the deepest, most extreme environment on the planet, life is sustained entirely by the dead. But perhaps the most revolutionary discovery in the deep ocean is not a creature at all. It is an idea that changed biology forever. In 1977, scientists aboard the research submersible Alvin descended to the Galapagos Rift and discovered hydrothermal vents. Cracks in the ocean floor, spewing superheated water rich with toxic chemicals like hydrogen sulfide. The water erupting from these vents can exceed 700 degrees Fahrenheit. The chemical cocktail pouring from these fissures would be instantly lethal to virtually every organism on the surface. And yet, clustered around them, in conditions that should sterilize all life, were entire thriving ecosystems, unlike anything science had ever documented. Giant tube worms, some towering over 6 feet tall, with no mouth, no stomach, and no eyes. They survive through chemosynthesis, harboring billions of bacteria inside their bodies that convert the toxic chemicals from the vents into usable energy. No sunlight required, no photosynthesis, no connection to the surface world whatsoever. Alongside the tube worms, eyeless shrimp swarm in the thousands around the vent openings, their backs covered with specialized receptors that can detect the faint thermal glow of the superheated water, navigating by heat in a world without light. Ghostly white crabs scuttle along the mineral chimneys, feeding on bacterial mats that thrive on the toxic outflow. Entire food chains, entire ecosystems, built from scratch on poison and heat. This was the first time in the history of science that researchers had found a complex, thriving community of life powered entirely by the Earth itself rather than the sun. It did not just surprise biologists, it shattered a fundamental assumption that had underpinned all of biology for centuries. It rewrote the definition of where life could exist. And it opened a door to one of the most profound questions humanity has ever asked. If life can flourish in total darkness, at crushing pressures, fueled by nothing more than volcanic chemistry and toxic gas, then what stops it from existing beneath the frozen ice shell of Europa, in the subsurface oceans of Enceladus, or in the methane seas of Titan? The deep ocean did not just reveal new species. It revealed the possibility that life, in some form, might be scattered across the universe in places we never thought to look. The deep ocean does not follow the rules we wrote for it. It does not care about our models, our predictions, or our assumptions about what life requires. Down here, fish see through transparent skulls. Jellyfish scream in pulses of blue light. Crustaceans survive for half a decade without food. Single cells grow to the size of a human fist, and entire civilizations flourish in boiling toxic water without ever knowing the sun exists. Every single expedition to the deep returns with something that challenges our understanding of biology, of evolution, of life itself. We have mapped more of the moon's surface than we have of our own ocean floor. Less than 20% of the seabed has been surveyed with modern technology. We know more about distant galaxies than we do about the world directly beneath our feet. The deep ocean is, in every measurable sense, the last true frontier on Earth. And right now, as you sit here, miles below the nearest coastline, in a trench so deep it would swallow entire mountain ranges, something is alive. Something we have never seen. Something we have never imagined. Something that does not follow the logic of the world above, that has never seen sunlight, that has never needed it. The deep ocean is not just a place. It is a reminder that this planet still holds secrets so vast, so strange, and so fundamentally alien that we have barely scratched the surface of understanding them. And the most unsettling part is this: we are not even close to finding them all. If this video made you see the ocean differently, take a moment to share your thoughts in the comments. Leave a like and subscribe to continue exploring the secrets of Earth's most extraordinary places. The deep still holds countless mysteries. Let's uncover them together. And if you want to dive even deeper into the bizarre world beneath the waves, check out the video on screen now. Trust me, you won't want to miss it. Thanks for watching, and I'll see you in the next video.